96% of all life vanished. This changes everything. A welcome to the Permian-Triassic boundary event. Before the dying, biodiversity thrived across these ancient seas. On land, complex forests and early reptiles dominated the world. But deep beneath Siberia, the planetary clock began ticking loudly. The Siberian Traps volcanism initiated the greatest mass extinction. But this wasn't a single event, but a sustained outpouring over millennia. The immediate effect was suffocating atmospheric poisoning. A massive CO2 release triggered runaway greenhouse warming globally. But terrestrial temperatures soared, devastating land-based life forms rapidly. The established Permian forests could not adapt to this new furnace. The resulting biome shifted dramatically towards barren wasteland. Now that we understand terrestrial stress, let's explore the oceans. Volcanic gases reacted with water, causing catastrophic ocean acidification. The worst still was the widespread, suffocating anoxia deep below. Large marine predators quickly succumbed to the low oxygen conditions. The base of the food web collapsed, leading to mass starvation. But geologists identify this turning point by a distinct, dark layer. Carbon isotope shifts confirm the massive input of volcanic carbon. And the sheer scale of the extinction is almost impossible to comprehend. The spore-pollen gap shows plant life virtually halted for centuries. Often, the eruption volume exceeded any other known volcanic episode in history. A rock analysis confirms the magma interacted heavily with buried coal seams. This interaction injected immense volumes of methane gas into the atmosphere. Amphibians, reliant on moisture, suffered disproportionately high extinction rates. The deep ocean essentially became a massive, anoxic biological desert. Even the smallest microbes faced unprecedented toxic conditions. The recovery phase took millions of years, fundamentally reshaping life's trajectory. The first survivors were often generalists, hardy and adaptable opportunists. The Archosaur relatives began to diversify into previously empty niches. The ecological vacuum allowed entirely new evolutionary paths to dominate. And gone were the familiar giants. The Triassic world looked distinctly alien. The environmental shockwave lasted for nearly 5 million years. Trace fossils reveal sluggish movement patterns during the recovery years. Oceanic recovery mirrored the land, slow and punctuated by setbacks. Unrepeated, smaller volcanic pulses prolonged the stress on surviving populations. This environmental filtering favored small body size and generalist diets. The configuration of Pangaea itself complicated the climate recovery efforts. Our shallow coastal seas repeatedly evaporated, creating hypersaline conditions. These evaporating basins further stressed surviving marine taxa. Paleontologists study this event to understand planetary tipping points. Modern models integrate volcanism, warming, and ocean chemistry simultaneously. The sheer duration of the crisis meant no refugia truly offered safety. Coastal environments, usually cradles of diversity, became immediate danger zones. Solar energy struggled to penetrate the persistent atmospheric haze. But only the toughest, most generalized terrestrial tetrapods managed to persist. The Great Dying acted as the ultimate, ruthless evolutionary bottleneck. And eventually, the volcanic activity subsided, and the planet began to cool. A marine fauna slowly re-established spiral growth patterns in the shells. The stage was now set for the Mesozoic era to dawn. And the lineage leading to true dinosaurs was now poised for dominance. The ecological niches of the Permian were completely rearranged. A genetic drift played a major role in shaping which lineages survived. But even the deep ocean chemoautotrophs showed significant disruption. And this event reminds us that planetary habitability is never guaranteed. Insects, with their hardened exoskeletons, showed surprising initial resilience. And these survivors carried the genetic blueprint for the next dominant forms. Over vast timescales, the carbon cycle slowly absorbed the excess into new rock. Life demonstrates incredible tenacity, but the cost of recovery was staggering. The Great Dying remains Earth's ultimate demonstration of biological fragility.